Welcome back from the lunch break. Hope you enjoyed. So we will start over to the next talk, presented by both are the founder and owner of DAS-IT, one of the conference sponsors, and both are also BAREOS founder and maintainer, co-founder and maintainer. Thank you. And they will tell us something about the new BAREOS release candidate 17.2. And now please provide a warm welcome to Maik Aussendorf and Philipp Storz.
Yeah, thank you. So since a couple of years, it's good tradition to present the new BAREOS version, or at least a release candidate, as last year. Also this year we have a release candidate published, which is now available on downloadbareos.org. And we are going to present what's new here and what's on the roadmap for next year. So, okay. Let's start. So this is the overview. We will explain some of the details later. So we did a lot of work under the hood regarding database optimizations, which is especially useful for users or customers that have very large backups by means of the number of files. And then Philipp spent most of the year working on the NDMP improvement. And then we have a new LAN address feature, which we will describe in detail. And Frank again continued to work on the web UI with a couple of new features. And then we have one feature here at the bottom line. The Amazon S3 backend connector is not yet in the packages that are published, but it's working, and it was funded by a customer, a large government institution in Europe. It's working there, but we are not ready with all testing and integration tests and documentation, so it's not in the official packages yet, but that will probably happen with the first maintenance release latest. Okay, so this was the overview. We start with a database optimization, or subsumized under the title file tame denormalization. The problem that we used to have is that when doing a backup, there will always be a record for the files that go into the backup. So, and such a record before 17.2 looked like this, at least parts of it from the file table. So you have a file ID and a job ID to which that file ID belongs. And then there's not the file name here in this column, but an ID. And this ID references to another table, which is called file name. And there you can look up and see, okay, file name ID 218 belongs to the name SSHD. So on this means whenever you insert a new record into file, when doing a backup, you first have to look up for the file name if it's in the table here, and look up for the ID. And that makes it slow if you have more and more file names in the table. So that will increase steadily forever, not linear, but by logarithmic means. So it will be a curve like this, but it will always grow. And if you have millions or billions of files, then it gets really slow. And we had one customer who's now a hosting partner from Canada with a lot of customers and millions of files. And they came up and said, why don't you denormalize the table? So that's more or less pretty simple, but we at first were very reluctant that changing the database scheme, a lot of effort, a lot of testing, a lot of problems. So at the beginning, we didn't want to, and instead we did some testing, because we said, okay, maybe there are other ways of improving the performance. And these were some tests with sets of 1 million of distinct files, distinct file names. And this is the number of the runs, consecutive runs, and this is the time it needs for the run. And the highest curve here shows how time increases every time new files get in. With BAREOS 16.1 and Postgres version 9.2. And our first idea was, before we change the database scheme, we try something else. We try to update to Postgres 9.5. Maybe that's already better. And you see, okay, with Postgres 9.5 here in green, it's already getting better, but not a lot, because it's still depending on the number of file names you have in the table. And the third approach was using the upsert function, which is let's say, a little bit more intelligent insert function, new with Postgres 9.5. And that is the blue line here. And that already got significant improvement, but still growing eternally. So in the end, we said, okay, this customer has the better arguments. And we did this, what we call denormalization. And here you see it doesn't make a big difference between Postgres versions. Both tests are with a denormalized database. And we see that the effort of inserting new file entries in the file table remains constant. So that's really a big step. I go one step back how we did it. So it's pretty simple. If you remember the table from before, there were two tables. And now we simply replaced the file name ID column by a column called name and directly writes the name into the table. The downside is it needs a little bit more space. So in earlier years, people used to normalize those tables to save some space for file name strings. But nowadays, that's not really a problem. And on the other hand, we get a constant time to for including files. So that's the advantages clearly supersedes the disadvantages. And yeah, so the results are speaking for themselves. And yeah, that's really good. Another problem that is that may happen is when you update, because and you already have large tables, then it may take some time until the tables are restructured. So be very careful if you have large databases and plan that you will need some time and also some space, as the tables will grow a little bit. Yeah. Sorry? Yeah, right. When you do the migration, then you need some temporary space, and at the end, table will get a little bit bigger. But on the other hand, it will be much faster for backups. Yes. Yes. Yeah. So there are scripts for MySQL and Postgres, and Stefan, for SQLite, I think not. No, because SQLite is intended for testing and not for big installations. Yeah, but there are scripts for both. But you really need to plan some downtime for the migration process and calculate if disk space is enough. Okay, more questions regarding, yeah? For restore, yeah, you also have to make the lookups with the older version. So, Stefan, have you realized any differences? Yeah. Yeah. Now they won't definitely slow down with a new structure, but it could be that they were slower before. But so we haven't made any measures, but at that particular customer, the solution is already in use. They have really a large set of customers and no complaints, so I don't expect any problem. Yeah. 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 Okay, then next is NDP, Philipp.
Okay, can you hear me? It's okay, it's sound? Okay, yeah. NDP two-way backup. So NDP is a relatively complex matter, and I would like to first introduce a bit to tell you what NDP is, and then explain what NDP two-way backup is, and also show, because we already were able to do NDP backups in BAREOS before, but that was a special way of NDP backups, and I want to show you the differences between the different ways of NDMP backups we can do and what the new things are. So what is NDMP? NDMP is a standardized protocol for backup and restore. It's usually used when backing up big filers or big storage systems like Isilon or like NetApp. It's supported by different backup applications also, and the interesting thing about NDMP is that as it's a standardized protocol, the storage vendor can itself support it by already having if you wish, the client part inside of the storage system. The elements of an NDMP system are DMA, or data management applications. That's in our case the BAREOS director, and this is the part of the system that controls the backup and restore operation and really tells the other parts what to do. Then there's so-called NDMP data agents. That's the part of the NDMP system that you would say in terms of BAREOS, it's the backup client. It's a standardized thing running inside of the storage system, and that's also the big advantage of NDMP. You can have so the storage vendor himself implements this client, so he can optimize it for speed and can access everything that's needed to quickly do a backup and to quickly do a restore. And that's also why usually NDMP backups work much faster than if you would mount the file system and back it up via mount. The third agent that's there is a tape agent. That's a relatively simple part of the system. It just offers a tape over the network, and the NDMP backup can the data agent then will connect to the tape agent and send the data directly to the tape agent, and it will directly write those blocks to a tape. And if one tape is not enough, then you also somehow need to control a tape changer or something, and that's the thing that a robot agent does. So a robot agent presents the SCSI changer device via network, and the DMA is then able, when the tape agent says the tape is full, I need a new one, is then able to load the next volume. So what's, yeah, already told a bit about what the things, the different elements do. So the DMA controls the backup operation. The data agent reads the data from the primary storage system and sends it to the tape agent. And the interesting thing about that is that the data agent, as I already said, is implemented by the storage vendor. So usually it is able to do the backups and restores very fast. Yeah, the tape agent, as I said, handles the tape, and the robot agent is able to change media. So there's different ways that NDMP backups can run, and that depends on where each of the agents is running. So there's an NDMP three-way backup, so-called. So you have a data management agent that controls the whole backup, and two-way or three-way is describes more or less the data paths that are used. So the three-way backup means that the data comes from the disk into the data agent, then it is sent over the network to the tape agent, and the tape agent then writes it to the tape drive. So you have three paths where the data is moved. The NDMP two-way backup means that you do not send the data over the network, but you have directly attached the disks to your storage system. That's usual, but you also can directly attach the tape drive to your storage system. And that makes it usually much, much faster, because the data does not have to be sent over the network, but the data can directly be moved from the disks to the tape without something else in between. Again, description what happens. So the advantage, the properties of the different topologies are the three-way backup. The flexibility there is that it's sent over the network, so you can send it over to a different network location easily. You don't have to attach tape drive to the storage system, or some vendors like Isilon even need a special device that is then attached, where you can attach the tape drive, so it's not included in your normal Isilon system. And it's usually slower because you have to copy the data over the network to the tape. And the two-way backup has the advantage that it goes directly from system to tape. It's really usually much, much faster, but you need to attach the tape drive or have a tape drive that you can attach to your system directly, or you, in the Isilon case, you have to buy an extra backup accelerator device to be able to attach a tape drive to your system. Something else that I need to explain, because that's something that we will that we now support, is DAR. DAR stands for Direct Access Recovery, and what that is about is that during the backup operation, the data agent not only sends the data to the tape drive, but also sends the metadata to the data management application. So it gets the information about what files and directories are currently being backed up, and the file rights, and some other information. So what we can see here, the file name and also the stat information. And additionally, it also can contain, depending on the implementation, file handle information, which is technically two 64-bit numbers in the end. That's the file handle info and file handle node information. And this is used for to be able to quickly do a restore of the NDMP backup. If you make a single file restore of NDMP backups without direct access recovery information, so that's what until now we had, so we did not store the file handle information with the file in the database. So it works like this. We have the list of files already that were backed up, and then we can interactively select what needs to be restored. In the end, this is created. This creates a restore file list, and this is sent to the data agent. And then the complete backup that has been done, which is technically it's just a very, very large archive, like a tar or dump archive, is completely sent to the data agent. The data agent will more or less scan the complete stream, and when it finds the files in the recovery list, then it will recover them. And this is, of course, very slow, because usually, especially when you are using NDMP backups, you have storage systems that have multiple terabytes or petabytes. And if you then have a full backup with 20 petabytes and you need to recover only one file, then in average it needs to restore 10 petabytes until it finds the data that it's looking for. And that's the problem that you have if you don't support direct access recovery. It will take very, very long if you only want to recover one single file. But if you have direct access recovery support, then you store the information that you get during the file handle information during backup together with the file. So you have, additionally to your file name and the stat information, you also have these two 64-bit numbers in the database. And when you ask it to restore, then together with this recovery list, you also send these two 64-bit numbers. And these numbers are created by the DMA during backup, and they are the address inside of the stream where the data that was just backed up is located. And this information is then used by the data agent to directly find out on which tape it is stored and in which blocks. And then it will automatically use the robot to load the right volume and to directly fast forward to the block it needs. And this will then only recover the files or the information that you really are looking for, and this speeds up by magnitudes your recovery speed. Another optimization is a directory DAR that's available. So if you have a lot of files that you want to recover, then your recovery list can become very big. And if it gets very big, then also the data agent needs to compare every file that's found during recovery to this list. And this can also slow down the recovery speed. And often you want to recover a full subdirectory. And then what directory does is you can then simply specify which subdirectory you want to recover. And it will only send this file, so the directory that needs to be recovered, and the data agent will automatically only recover everything that's in this below this directory. I hope that's understandable. So of course, when the backup is being run, it recurses through the directories, and when it starts to go into a subdirectory, then it memorizes which block this was. And when you recover, you only have to fast forward to the start of the recursion of this subdirectory, and then it will recover everything that it finds in the stream until this directory is left. As I said, NDMP backups were already possible in BAREOS before version 17, but we had a special, it is still available, but this is a special way of the three-way NDMP topology, because in this version that we had before, the storage daemon implements a tape agent with an infinitely long NDMP tape. So the backups are done that way that the data agent is told that it needs to contact on port 10,000 to a tape agent that's emulated by the storage daemon. And as for the data agent, it looks like an infinite tape. It never needs to, it never gets the information that the tape is full, and it also never needs to do any robot interaction. And inside of the storage daemon, then this incoming stream is stored as BAREOS file into normal BAREOS backups. So in the end, for BAREOS, it looks like a special file that has a big size, but it's not really an NDMP thing. The file name information is then in BAREOS linked to this archive file, so that when you select a file from the NDMP backup, this points to the real file, which is the archive, so that it knows which file really to send back to the data agent when restore is done. The problem with this is that we don't have file handle information. We are not able to translate file handle information, which is the block address inside of the virtual file, to the real block addresses where the data is stored inside of the BAREOS stuff. So we don't support direct access recovery. And to be able to distinguish between this special of NDMP and the things that are available now in version 17, this is called NDMP BAREOS because it's not NDMP 2-way, it's not NDMP 3-way, it's something special because we emulate an infinite tape drive. Let me see what the properties of NDMP, what I didn't mention before. The advantage that we have with NDMP BAREOS is the data is stored as a single file as other single files also in BAREOS, so we are able to do copy jobs and migrate jobs, which is an advantage. Yeah, that's a special thing. The other things I think I already mentioned. And what was added now to version 17 is the native NDMP implementation, which means that the BAREOS director is now the data management application, and it really only does speak NDMP to other NDMP agents, but there's no special thing like before. So the BAREOS storage daemon is not involved at all. The complete NDMP backups are only done by the director and by native NDMP agents that are not supplied by us. The director now needs to do the media handling in NDMP way. It also needs to control the robot and the data agents now. We also now store the file handle information and file handle node inside of the database when we get the file handle information for every file. and that leads to us to be able to support direct access recovery, which is the main advantage of the new implementation, because when you have really big backups and you want to do recovers, direct access recovery is mandatory, otherwise you will really wait too long to get your data back. Small table as finish of this NDMP presentation is where you can see the different properties compared of the NDMP BAREOS special implementation we had before and the native implementation we have now. And I think the most important things are that we now have two-way backup, so we are able to really fastly backup NDMP storages that are usually very big. If you directly connect your tape drives and your robots to your system, then the backup is really fast. Also, DAR and DDAR is now supported, so both work. And the disadvantage is that you are not able to do copy or migration jobs. That's the part of NDMP. Any questions? Does anybody use NDMP? Okay. Okay. So far for NDMP. Then want to.
When the untested feature to three-way.
This one, yeah.
Three-way backup. Is this BAREOS SD not involved?
Exactly, yeah. So the native version really does NDMP like it is conceptually created. So like it's thought to be. So in NDMP BAREOS we did some special things, and this is really a native NDMP implementation. The customer that we developed this for definitely wants two-way backup, and that's why we extensively tested this one. But in theory, there's no really reason why this shouldn't work. But I didn't test it, and probably there might be some small things where I have forgotten something to implement. But that's just the setup in the end of the NDMP state machine that you need to do a little bit different so that it doesn't connect to the same NDMP port. Because the difference is, let me quickly go back. When you have two-way backup, the DMA only connects to port 10,000 here, and there both agents can be connected.
Yes.
So, and if I do three-way backup this way, the DMA needs to connect to a different port and the tape agent and the data agent, and that's the difference how you need to set up the backup job in the NDMP state machine.
But the tape agent is the SD, no, or no?
No.
In this way,
no.
Where's the data sent in this way?
You have here an NDMP tape agent running on port 10,000 that has nothing to do with BAREOS. And the only difference between the three-way and the two-way backup is if they are both running on the same machine or not. And the old way we had, this tape agent was inside of the storage daemon. Mm-hmm. And it didn't really go to a tape drive, but into a BAREOS storage daemon device.
Yes.
And this is now really a SCSI fiber channel tape drive connected to the machine. So usually what most people want is this. So if it's this way, then you have directly, for your NetApp filer, for example, there's a fiber channel port, and you directly have plugged in the fiber channel port into the tape drive into that fiber channel port. And the storage system itself will save itself onto this tape.
So I need a separate tape drive for this?
Either a separate tape drive, or if you have fiber channel and a fiber channel switch, and you can do and you can present it there. So what usually happens is people have a fiber channel switch with different zoning, and then they present a tape drive that they want to use to this machine, and it will then see this device and store there. So you really get via NDMP, you really get def, NST, whatever, and you can say use this for backup, please.
Okay, thank you.
You mean the three-way? This one, you mean?
Yeah.
That's what I just said. I only have tested extensively this one, because that's the reason why we implemented that, and the customer asked for that. In principle, there's no reason why this shouldn't work, but it's not tested, and I expect that maybe some problems could happen, because inside of the DMA I have the NDMP state machine, and if you want to use a data agent and a tape agent on different machines, then you need to differently set up the NDMP state machine, because your tape and data agent are not on the same machine like they are in the other setup. And that's the only thing. So if you want to use it the other way around, please test it and tell us what you find out. Probably there's a small problem and we have to check out, but that shouldn't be a big problem.
Are you using NDMP with BAREOS right now? Yeah. Okay, so then there's still BAREOS and this is unchanged before.
Yeah, the old way is still available, yes. Yeah. So the old way is not removed. It just, we only support others, the new ways. Okay, more questions for NDMP? No? Okay, then one more feature I would like to present, that's the LAN address feature. The idea behind that is that we have a customer that does backups for their clients, for their customers, and usually they have a mix of file daemons and storage daemons inside of the customer's local area network. They have usually a network address translating firewall here to the internet, and this is, in the internet they have their director, they have their own also file daemons and storage daemons. And what they wanted to be able, or where the problem was before, is if you want to make a backup and tell this file daemon to back up to this storage daemon, usually the director sends through the control connection where this storage daemon can be reached. And therefore it uses the address that itself uses to connect to this machine. But unfortunately in this case, when the director wants to talk to the storage daemon, it needs to connect to 88820 in this case, and this is translated to 10.0.0.20. But if you want to make a backup of this one that should go here, then of course it should not use 88820, but 10.0.0.20, because it's inside of its subdirectory, subLAN. So that's the idea. Usually what you do to solve these problems is you don't use IPs, you use names. And then you can just say, for this machine, SD LAN has this IP address, and for this machine, SD LAN has this IP address, and the problem would be solved. But the customer says, I don't have any access to control anything inside of the local area network, because that's what the customer does. So this is a problem that we try to solve. Here you see how the configuration is. So as I said, the director has normally an idea about how he can reach every part of the system. And when it tells this client to save to this machine, then it tells him, please use this address. And as I said, if this machine inside of the local area network wants to connect here, it does not need to use this one, but the address that's inside of the subnet. The address, the idea how to do it is that we additionally to an address can configure an additional directive, which is called LAN address. So we now have a file daemon that has an address and a LAN address setting. And we do this for the file daemon and for the storage daemon that have two addresses. One is the one that the director tries to access the things, and the other one is for information purposes that there's also a different address that can be reached. And the logic that then works is when you start a backup, then the director looks up, do both parts that are involved into this backup have a LAN address or not? And if they both have it, then I tell them to use the LAN address. And if only one of them or none of them has a LAN address, then use the official ones. And this leads to the nice effect that you can back up everything everywhere. So you are then able to use to run the backup from the FD to the SD in the LAN. You can run a backup from this FD to this SD outside, and otherwise, as long as, of course, the firewall allows these connections. So it's quite flexible this way. I don't think that many people have this problem, but I think we solved it in a nice way. Okay, any questions regarding this feature or? Okay, that's it then from my side. Thank you.
Okay. I just want to add a few words about what's new in the web UI. So one thing is a progress bar for each running job, and it's good that we have a screenshot here because in the demo system we have there are only small jobs. So even if I start one, the progress bar would be disappeared before I've reached the right page. Just a moment. But another thing that's new is that when running a job, before it was only possible to run it with the default settings of a job, and now if you go on run, you can select any configured job, and then if you want, you can override the defaults. Of course, you can still leave everything as it is, then it will take the defaults, but here you can now change whatever is useful. Maybe if I set this to full, I get a chance to see the progress bar. You can also change the day when it should run. And now I try to submit it here with changed parameters. Going quickly back to the dashboard. And it's already done. So, but normally then here you would see the progress bar just as shown as in the screenshot. Another thing that's new is if you go to the jobs list and select any job here, then you have a new part on the screen here which says used volume. So you can directly see here in the web UI which media are involved with this particular job. So that's new. And I think one other thing. Right, the languages. Just a moment, we go back to the screen. So here's again the Here's again the screenshot with the progress bar. So of course this does estimation, but it will show any job. So if multiple jobs are running, you get for each running job the progress bar, which is sometimes good for administrators to see how things go on. That was the customized jobs. And some new languages. So with this version, you are Slovak, Turkish, and Czech. And for completeness, before we already had those languages here. And apart from German and English, almost everything came from someone from the community sending in translations. Okay, that about the web UI. Any questions regarding that part? Yeah. The question was regarding restoring MySQL databases. That is not supported by the web UI. So you can trigger the job, but it won't probably not call the plugins on the right way. Yeah. It's Frank. I guess it's somewhere on the list. Yeah, not very soon. Okay. Yeah.
How do you calculate the progress? Calculate.
I hand this over to the developer, Frank.
It's a long time. I have to look at the code, to be honest. I have to look at the code, how it's really done, because it's a long time ago I had done the programming for that. But yeah, we can meet at the floor in the break, and I tell you more details on that one.
Yeah,
we
probably
also-
looking at the old jobs, how big they were, I guess, because otherwise it's.
Yeah, we'll find out, and Frank will be outside with the laptop anyway, so then you can have a deeper look at the web frontend, and Frank will check the code. Okay, any more questions regarding the web UI? Okay, then we come to the last slide of this presentation, and that is what we are planning to do for the next release. So one thing is that we want to enable TLS encryption by default without anything being necessary to configure, in a very simple way, so that we simply use the passwords as pre-shared keys and start TLS if not disabled by the administrator. So of course there are better ways of generating keys, but this is already much better than no encryption, and it will simply enable it because it has no disadvantage but only advantages, and if someone wants to use other keys, it's still possible to do it the old way. And that's, I think, development is pretty far. We were considering putting this into 17.2, but it was not 100% ready, and we didn't want to change the default behavior of something that we did not test very intensively. So this will come with the next releases. Okay, then for the web UI, there's one thing missing compared to BAT. You may have heard that we have dropped BAT from 17.2. And that is the version browser. So with BAT, you could, in the restore browser, graphically browse through different file versions that are present in the backup system. This functionality is not yet in the web UI, but we'll get into it pretty soon. And then we will work on the view of available backups for a client. We're not 100% sure how we will do it, but we want to improve the presentation because it's sometimes not that handy. And then, yeah, performance graphs. I've looked at the presentation from last year, and exactly the same topic was there on the list, so it's still here, and we hope that we will do something in the next year. Okay, then Philipp, das kannst du was erklären. Change the build system from AutoTools to CMake.
Yes, yeah, that's I think not interesting for the end users, but for the developers maybe, because that's already quite far. So we want to change the build system to CMake, which makes things much straightforward. I don't know if anyone of you has worked with AutoTools, but they really are a pain. And CMake does things much easier, and everything is in one tool. So that's why we will change the build system, which is quite a lot of work to do now, but it will save us a lot of nerves and time in the future, I think.
Yeah, and then one point that comes from customer requests is support for more Unix binaries, at least for the client part. So we have all the packages for Solaris. Now we have a big new customer that wants us to build HPUX packages. Another one wants AIX, and yet another one wants FreeBSD. And we have already started to work on it. And so that will be better for the next time. And then lastly, and that is something that is really a good point, so we get more and more subscription and support customers, and now we are in a position that we can extend the stuff by developers and people helping us in support, so that we will be able to speed up development even more than we already did in the past. But yeah, things are developing in a very good way, and we hope that this will improve over time, of course. So, any questions or suggestions regarding the roadmap? Okay, then we can get to the next one.
Thank you.